When the world was first created, fragile elements disappeared and later scientists found holes in their periodic table where these elements should have resided. Just before World War I, in the University of Manchester, England, scientist Ernest Rutherford, a lab director, had a student named Henry Moseley, who worked all day at physical sciences. He studied elements by blasting them with electron beams. He joined with Charles Darwin's grandson in 1913 to test every element up to gold. They found that when the electron beam hit the element, it left a hole in the space where the atom's original electron previously resided. This caused high-energy X-rays to be released as other electrons tried to fill this empty space. Moseley found a mathematical relationship between the wavelengths of the X-rays, the number of protons of the element, and the atomic number or location of the element in the periodic table. Since 1869, Mendelev's periodic table has been changed multiple times. It was originally on its side. It was Moseley who proved that there was an order to the atomic numbers with protons. Moseley filled spaces 43, 61, 72, and 75 on the periodic table with his results. Theoretically, he would have been able to find 85 and 87 and 91 if not for the fact that he could not get a hold of the heavier metals in 1913. When World War I started, Moseley was recruited for the King's Army and fought in the Gallipoli campaign of 1915. He ended up dying in the war. In tribute to Moseley, scientists tracked down the missing elements Moseley found. Elements 85 and 87 were later discovered in a lab in the 1930s. By 1940, the only element still undiscovered was 61. In 1949, 3 scientists in the Oak Ridge National Laboratory in Tennessee announced that they had found element 61 during their research into uranium. They informed other scientists that they had discovered this element 2 years previous, but were too preoccupied with their research to tell the public. The scientists named the element Promethium after the Titan in Greek mythology who stole fire from mankind and was tortured by having his liver eaten by vultures. Scientists had agreed that element 61 was essentially useless. In 1939, at the University of California, Berkeley, Luis Alvarez came across an article in the San Francisco Chronicle about Otto Hahn in Germany, who had found fission by splitting a uranium atom. Alvarez ran across campus to find a Geiger counter and irradiated uranium to test this new information. Rutherford had previously found alpha, beta, and gamma decay occurring when the nucleus emits concentrated X-rays. In the 1920s, it was discovered that other types of radioactivity involved the conversion of one element to another. In 1932, James Chadwick, another of Rutherford's students, discovered the neutral neutron that added weight without charge. This helped scientists better understand the periodic table, isotopes of elements, and the different forms of decay. They found that beta decay changes the number of one proton, while alpha decay changes 2 protons and 2 neutrons. Scientists found that the most lighter elements tried to keep a 1-to-1 ratio of protons and neutrons, but when an atom had too many neutrons, it split itself and released excess energy and neutrons, which were then picked up by nearby atoms, who then released the excess neutrons and energy and continued in a chain reaction. In 1933, physicist Leo Szilard created the idea of a chain reaction. He patented his idea in 1943, but was unsuccessful trying to prove his theory on lighter elements for the next 2 years. With scientists probing unstable elements, they soon discovered nuclear fission and neutron chain reactions. In World War II, rather than having all scientists develop faster weapons and stronger steel, the United States government invested billions of dollars in subatomic science. Scientists wanted to create a chain reaction that let loose billions of neutrons moving at different speeds and directions. The Manhattan Project scientists had orders to find out how much plutonium and uranium was needed to create a bomb. Scientists tested the amount needed with random numbers for speed of the reaction, speed of the neutron, random direction, random parameters, random amount of plutonium available, and random shape of the substance used. Women were hired to crunch these numbers over and over again for the scientists to analyze. They found that the particles on the quantum level were governed by statistical laws and quantum mechanics, and this method ended up being the most accurate scientific theory had created. In the mid-1945, the scientists had created their first atomic bomb, which was tested weeks later at Trinity Site in Mexico, and then dropped on Hiroshima and Nagasaki, Japan. In 1950, Leo Szilard found that if the world was covered in 1/10 an ounce of cobalt-60 on every square mile, the human race would be wiped out. Cobalt-60 bombs would settle cobalt dust on the ground below them, and it would take 100 years for the land to recover. No country ever tried to build a bomb such as this, but it showed how probable the idea of nuclear warfare could become, and how strong the fear of this would generate in the coming years of the Cold War.